Today's speaker is Dr. Jae-Gan of the Mobians from Korea. And Dr. An studied mathematics and computer science at Korea Advanced Institute of Science and Technology, one of the premier research universities in Korea, funded by the Korean national government. And he went on to study computer science, majoring in computer graphics at Pohang Institute of Science and Technology, also in Korea, funded by the world's second largest steel company, POSCO. And then after that, he worked at the Electronics and Telecommunication Research Institute, also in Korea, kind of the Bell Lab equivalent of Korea, I would say. And then after working at E3, he founded the current company, which is Mobians.com, and in 2003. And today's topic is going to be MobileQWERTY keyboard for special mobile and special need. So let us welcome Dr. Han.
How are you doing? Okay, thank you for introducing me. Okay, I'm from the Mobians company, and our company, actually before the founding my company, I had a small idea about text input, and actually researching and developing for several years, we found a very useful steps, useful way to applying this solution to different devices. And so that's why I came here to just to let you know that what those text input solution is. So the title is MobileQWERTY keyboard. Actually, by MobileQWERTY keyboard, I mean a small, simplified, universal keyboard, which is a simple structure. And actually, the name, can you guess what that means? That is actually a mobile version of QWERTY keyboard. The QWERTY keyboard is the keyboard that people are using every day. So we want to make some equivalent keyboard for mobile devices, as well as the keyboard for the handicapped people, because the handicapped people is very hard to use the real keyboard. Actually, you can see the contents. Next slide. Okay, let me start by showing the keyboard that you are familiar with. Actually, this is the computer keyboard. There's many computer keyboard types, and the core part of the computer keyboard is actually the layout there. There's the layout called the QWERTY, QWERTY, starting from here. So it is called QWERTY. So QWERTY keyboard is the central part of the keyboard, and there are the numbers, maybe the symbols, and the functions, and the cursor movement keys, and some modifiers around here. So this is actually the core part of every keyboard. But actually, you know, the keyboard are practiced using both hands and 10 fingers. So let me show another examples of keyboard. These are small keyboards applied to maybe the smartphones or the mobile devices. You know, here, actually, you can say that this is the QWERTY keyboard and this is the QWERTY keyboard. Actually, they are different. Can you see? There's no actually number buttons here. There's number buttons here, and the symbol arrangements are different. So if you are became familiar with this one, you will also have to practice a lot to make you familiar with this keyboard. Okay, these are another examples of the same keyboard, but actually they are different. Small sizes and different variations. And these are actually the keyboard, and this is the actually 1 year ago I found this one from the on an airplane, Singapore Airlines. They are serving the OpenOffice software on the plane. And this is the keyboard for the OpenOffice. And I tried for several hours during the flight, but actually I couldn't do any editing with this keyboard because there's no function keys here, there's no alt keys here. So if you are to use the OpenOffice, like the Microsoft version of OpenOffice, you have to do a lot of commands here. Without actually the shortcut, it's very slow and very difficult to. Actually, the typing is also difficult, and there's a lack of functions there. So this is not actually good for OpenOffice. So after the talk, you may guess that our solution is far simpler than this one, but provide full functionality for doing that kind of job. Okay, this is another keyboard, on-screen keyboard. You can see the differences here. So these are hardware plugins for small mobile devices. They are different. So there are many actually implementations of real keyboard, but actually these keyboards are mainly for the alphabet input, not the keyboard function. And actually these are, I can say that these keyboards are actually different for users' point of view. Small sizes and many variations. So you have to practice a lot to make you familiar with each of these keyboards. So these are actually the different implementations of the so-called computer keyboard. Actually, this is the second part of my presentation, the examples of presentation. Okay, these keyboards are for the handicapped people. The one here actually uses his single hand and single eye to input with the keyboard. And this lady are using the joystick to move the cursor around on the screen to select the letter she wants. And actually, these two children may not be handicapped, but the children can't control their fingers precisely, so they have difficult time to practice the keyboard. And these two guys are using their feet to type in, and this guy is using his eyes to input the text. There's on-screen keyboard here, and he controls the cursor around the screen with his eyes, and just looking at the keyboard for 2 seconds, and there's happens on input. So actually, this lady and this man using the mouse to control the cursor here, and the mouse to push the keyboard using the stick on the mouse. Actually, these keyboards, this is our opinion about the situation. Actually, handicapped people are actually very serious in practically using the IT. But actually, they have to use the computer keyboard to use the IT technology. But actually, the forms here, the keyboard forms are actually for normal people, not for handicapped people. So it's very difficult for them to practice. So we need some kind of simpler form of keyboard, and of course we need to provide the perfect functions for keyboard. And the fifth point is that children and older people, we just grow older and older, and I may be trembling my hand later, but I have still used computer. So this may be for me. So children and older people can actually precise control their hands and fingers. So I just want a kind of simple form of keyboard for them to really enjoy the IT technology. Okay, this is actually the point that I have shown on the slides. Actually, the current structure of your keyboard is not actually good for mobile and handicap situation. This is just for the ideal text input solution for ideal actually solution for computer use and in normal computer environments. But it is rather actually complicated and is not suitable for mobile and handicap situation. And I think that it can be actually squeezed into 3x3 structure, the whole keyboard thing. Firstly, the letters, the alphabet, symbols, numbers can be put into 3x3. But actually, you can squeeze into 3x3 in many ways, maybe millions of ways. But I think we have found actually a very easy way that actually you are already familiar with. You may see what I'm talking about. Okay, all the letters are going into 3x3 way, and actually the other functions, keyboard functions, function keys, cursor keys, and the modifier keys can also be put into 3x3. So by doing this way, we just put whole keyboard into 3x3 structure, and actually this one actually is good for mobile and handicap situation. And if the 3x3 structure can be applied to many different kinds of devices. You can see actually normal, the natural mapping between the 3x3 structure and the button device there, and the pen devices here, and joystick devices, and the miscellaneous devices together. And also it can be applied to this one, or this one, using eyes, with joystick, and the gesture. you can also put into this. I can shortly explain how you can input with the 3x3 structure and the kind of device. Actually, instead of me to explain you, you can imagine how you can utilize the 3x3 structure with this kind of diverse devices. There's a natural mapping there. I can show later with this one about inputting and doing the keyboard functions later, but because time is short. Okay, this one is actually the same as the previous slide, but if the joystick is just 4 directional one. You just can't direct the diagonal direction, but you can still use the same concept. You can see the factor summation there. So if you want to enter, for example, in number 1 button, you can combine the left direction and up direction on the left side or right side, or you can push it twice on single hand to get the number 1 direction. So that way you can actually make the input. Actually, this is just for maybe the MP3 player, digital camera, or the gamepad device, but handicapped people can also use that. On the thumb, both thumbs, they can attach small joysticks there so they can practice, even without directing the diagonal direction, which can be maybe difficult for them to direct. Okay, this one is the conceptual picture of how you can input with the eyes. Actually, if you are watching this direction, the camera can tell you are watching the number 1 direction. So there's just one-to-one correspondence. You don't need to move the cursor around the screen, which is very difficult. So the cursor is here. If you want to enter something, you can watch the direction and make something. Maybe you can blink eyes to select something, or you can push buttons, or you can move your jaws, or anything. You can move maybe your tongue, and so on. So you can also see the natural correspondence between the 3x3 structure and this one, maybe this one. And you can also combine any elements together so that normal people can actually do with any single one, but according to the degree of the handicapped people may find useful if combining different devices together. So this one is actually, I'm showing the layout there. I'll explain the layout in detail in the next slides, but actually the layout is invented that way. You know, in the number 1 direction, E, W, Q is here. So the first letter in the color red letters here occupy 70%, and the green letter occupy 25%, and the blue letter occupy just 5%. So actually, before going, let me just demonstrate it. Okay, with the pen device, this is an easy way. This can be actually for normal the mobile device or the handicapped people. The first letter, second letter, third letter. What I mean is, let me just shortly demonstrate it. Okay. Okay, this is the first letter, E. Actually, normally you need to press actually in the multi-tab way, E, W, Q, right? E, W, Q. Just if you are using actually the ABC layout, you can input A, B, C right there. But if you're changing the way to select, actually the pen way, the first letter A is selected by touching it, and second letter B is selected by stroking it, and the third letter is input by the checking it. So that's the first, second, and third. Actually, with this ABC layout, it's very difficult, but let me short demonstrate it here. It's a simple sentence here. For example, this is a difficult part. Actually, H, O, and E, W. I mean H, O, W. But you can also connect those elements together to get the how. So let me just shortly demonstrate. Okay. Maybe that way. You can input that way. Okay, let me show later in detail. But the idea is that in each button, you just draw some action there, dot, stroke, and check to get the first, second, third. And you can also connect those elements together so that you can just put the pen down and draw something and you get the result. So this can be useful for the pen device or maybe handicapped people. So here, let's go into the layout. So I think the layout is important. If you know the layout, you can use your maybe the big hands, foot, eyes, anything. You can do the input, real input, but the layout matters. You have to memorize it. But you know, how many people here can perfectly memorize the current standard layout? I mean the ABC layout. Maybe some people can memorize it, maybe, yeah. But most people don't memorize it. There's a reason, because we did some experiments with the actual professors in our country, but they concluded that there's many reasons, psychological reasons and so on. So there's okay, let me introduce the MobileQWERTY layout and the ABC layout there. The red letters 70%, I said earlier, and this 25% and 5%. So actually, the average number of button presses per letter, you can lower down into 1.35 per letter instead of 2.14 per letter for ABC layout. And you can actually see you can actually guess where E should be. It must be the first position in some button because E is the most frequently used letter. And if regarding maybe J must be the third letter in some button, right? Because you can guess the letter's frequency. And another, actually, this is the ABC layout and our layout. Actually, we at first started with the English language alone, but we found that the other languages also show the similar characteristics. This is average 2.2, and these all show the average 1.35. So we concluded that in average, they show similar actual behavior across languages. Actually, and this is what I'm saying that you are already familiar with the MobileQWERTY. You can see the directions there. Maybe the next slides will show you more clarified. Okay, the actual QWERTY is 1 per letter, but ours is 1.35 per letter. Okay, here's QWERTY, MobileQWERTY, and ABC. 70% letter, 25, 5. And the number of button presses is just, you can compare it, 1, 1.35, 2.14. Actually, this is a big difference here compared to this one. And another is that you are familiar with the layout. You divide the whole layout into 3, left side, right side, and middle side. So where is E? E must be on the left side, right? J is on the right side, T is on the middle. You don't know the exact position, but you roughly know where it should be. So left letters go into the left column, and the right letters go into the right column, and the letters in the middle go into the middle column. And I just removed 8 letters. There's 18 letters there, because 8 letters, actually, we have to remove it for the moment. I divided it into 3 by 3. So QWE goes into number 1 position. You can guess why, right? But the order is EWQ, according to statistics. This is number 2, number 3, number 4, 5, 6, 7, and 8, 9. So this is another way to describe the directions here. So seeing the QWERTY keyboard, you know roughly the direction. So that's all. If you know the direction, then you know where the letter should be. And you also know the ordering in each button. You know the statistics by practicing it. 70%, 25, 5 are so different figures. So you can guess where it should be, the column. And the remaining letters actually, here, actually I and O is just, they are neighbors. But here, O is up and I is down. There are so many, there are many reasons. So we found that I is better to be down there than O. So we just chosen that way. But you can see actually the similarity here at IR and SGH here. And the remaining 3 is Z, V, K, and this way. So this is our MobileQWERTY layout. And this is an example from 1 to 10 inputting. 1 is input this way, right? O, N, E in the keyboard. You don't need it to stick into the real buttons there, but the rough graph is there that way. So you can guess 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, you can actually input similar to the real QWERTY keyboard on the 3x3. This is our test result. We wanted to some we had to select some sentences that can be measurable. So we found the sentence there that is used for measuring the Guinness World Record. Who is the fastest man in the world with the handset? So actually, with the computer keyboard, it was actually this guy is not an expert on typing, but it took 20 seconds to complete the input here. It is 164 button presses. This whole, and with ABC handset, it is more than 300 presses, and the time taken is more than 40 seconds. Actually, 2 years ago, it was 67 seconds, and then the time gets lower and lower until to become 41 seconds here. But with our MobileQWERTY, the button presses become 212, and the input, the time taken to input is just 30 seconds. So, and the other part is that actually, because of the time limit, I actually omitted the detail. But you know, the QWERTY want to be on the mobile devices. So the whole keyboard is divided into these components. You have seen only this one, but actually the remaining things are actually very familiar to you maybe. This one is a natural layout here. And actually this one, I think this is also familiar to you, the natural. Do you know why? Where do you think tab is better to be here? Where do you like your backspace to be there? Where is space? Where is enter? So I guess tab is here naturally, and backspace is naturally here, and space naturally is here, and so on. So if we divide the backspace to be here, tab is here, enter is here, maybe space is here, so it may be confusing to you, because that makes not the keyboard, QWERTY, and MobileQWERTY not conformal to each other. So we just wanted to make some maximum conformality between the QWERTY and MobileQWERTY. And let me show you, actually the 3x3 can be extended in another structure. This is just an animated or maybe cartoon, maybe you can think of that. 3x3, we just think about the direction, up, down, left, right, and diagonal directions. And you can also expand the functionalities of each button that way. You can also push away the buttons in the diagonal directions there. So you can press this one or this one together. I can show you later with the actual device here. So, and by actually collecting those 3 buttons here, this is actually the structure for handset, I think. And actually by making this form, this is an actual emulator that you can download from our website. This is actually we wanted to, for the remote control more suitable, and you can also divide it into for the dual hand version of the same layout. And this is the overall picture of this 3x3 structure. You can see the layout here. Most important, the factor in keyboard, the alphabet layout, MobileQWERTY layout here. And the tab, backspace, maybe enter, space, and symbol, separation, and so on, we just put there. And they can have skin like that. It can have skin like that, or like that. So this one is actually for the joystick devices and so on. Actually, you can also use this one, but this skin more simplify the process of inputting. This one just for the remote control like thing, and this one maybe the UMPC style input using dual hands, and this one just for PDA style. And actually you can also make the whole screen into 3x3, and you can touch it to input. I can also show you the demonstration later. Okay, this is the what I'm thinking of, what we think about the conceptual keyboard solution. There had been QWERTY 140 years ago. Christopher Schulz invented it, and they sold to the typewriter company. And there had been Dvorak keyboard, but actually there's not so much speed increase. So people already know QWERTY. So actually QWERTY, Dvorak doesn't succeed in the history. And IBM actually invented the current form of keyboard in 1980s. And nowadays, we are using the computer keyboard in many shapes, wireless or the natural shape and so on. But there are lots of small, powerful devices that one has a kind of keyboard. Without actual keyboard, you just can't fully utilize the mobile devices, powerful devices. So, but the QWERTY is not natural to be integrated into small devices. So we just want a smaller form of QWERTY. I'm insisting that MobileQWERTY is the thing, the simpler form. So we can devise many interfaces and many devices that way. So this is the flow is actually the QWERTY. So we just want a mobile version of QWERTY that makes the life easier for users to learn and practice and so on. And another technology may be the handwriting, speech recognition, and artificial intelligence actually are different subjects. So we just I don't want to discuss about that. But those technologies actually should someday benefit users, but not yet, I think. So this is our idea on our solution. Our solution, we want it to be a framework, a kind of framework, so that we can extend it to fit to different devices, and the manufacturers can adapt the interfaces here to produce products, and the users just buy it and instantly use it because they already know about the keyboard. If you buy a keyboard, do you study a lot? Do you practice a lot? Because you know the layout, whole layout. It's instant. If you buy the keyboard, you can instantly use it. So I just want it to be the same for mobile situation and the handicapped situation too. So this MobileQWERTY equipped with natural and intuitive device interface. You can provide the solutions here, and also the solutions for the handicapped people. Okay, after the conclusion, let me show some small demonstrations. Okay, this is actually a small conclusion. The structure of QWERTY is not just appropriate in mobile and handicapped environments. And 3x structure actually is very convenient to devise new interfaces, very natural and intuitive interfaces. And the ABC actually is very strangely hard to memorize. And the MobileQWERTY layout, we divided it to be maximally efficient. The first letter, the most frequently used letters. In that way, this is actually maximally efficient one, and because of the QWERTY, it's very easy to memorize. And the fifth argument is that MobileQWERTY actually, that is actually the layout there, EWQTY, but just like the QWERTY layout is the central part of QWERTY keyboard, which is MobileQWERTY is a fundamental actually way to the problem of alphabet input. And we think that it's a 3x3 structure with the core MobileQWERTY layout can make the simplified universal keyboard working for mobile devices and handicapped situation. Okay, let me demonstrate with an example here. Okay, this is actually the 3x3 one here. I'm just briefly will demonstrate how you can input with the 3x3 structure there. So if you just pressing it, E, W, Q, this is it, right? What do you guess you should input to maybe input the tap letter there? This is a touchscreen device, so you can make some different way to tell. You can draw it here, right? This is tab. This is backspace. This is OP. This is enter. So by touching it in multi-tab way, in stroking it, you can distinguish two different kinds of input. So you can use the combined layout, alphabet layout and the keyboard layout combined together in 3x3. You can tell how to input. For example, H, O, in W, and this is a symbol and question mark there. And another way is to actually, I have thrown the layout away, and actually this whole screen actually is divided into 3x3. Actually the same, right? This is H, this is O, this is W. No. E, W. So actually, this is 1, this is 5, right? This is 8, this is 9. You can roughly guess where the location is. This must be 6, so you can actually by dividing the whole screen into 3 by 3, you can actually guess where it should be. So if you know the layout, then you know where E is the letter. How? R, R, the symbol, that way. Okay. And another way to input is using in a multi-step way. Let me shortly demonstrate one example here. Let me, for example, this maybe is a test with the, how about with the ABC layout here? It's a long way actually. It's a long way, and if you want to use the drawing way to input with the same layout, actually this is also a long way. I'm not acquainted with this one. Maybe this way, but we using the mobile call layout, the frequently used one is at the first, so this is a simple matter. So this way. And actually, maybe you can change the skin. I have shown you that this is actually the 3 by 3, conceptual 3 by 3, expanded in 18 letters and buttons. But you can see that this is on derivation from 3 by 3. So there's a cursor movement here, and you can also maybe have here. Maybe you can close it down, or you can maybe actually pop up, and you can also do everything here. So in that way, you just want to make the text inputting here and the keyboard control here. So actually, this is just the same one with the hiding the layout here. So you can actually input the same way, right? H, O. I. So you can, if you know the layout, it's a very intuitive for you to practice it. And the next one is using this joystick here. So I changed the skin like this one. You can also use the stick skin, but this is more natural. This doesn't. Oh, the computer doesn't recognize the device here. Oops, I plugged in different thing here. So you can see the directions here, right? So if I want to enter, this is H, O, and W. How can you input with this one, the space there? Actually, the space here is the same position like the bottom here, down. So actually, there are many buttons here. So you can distinguish it, right? This is tab, space. Maybe this is A. Maybe this is keyboard. Okay. So if you want to select the buttons outside, you can push a button here. And if you want to enter the inside one, you can push another button here. So if you are using 2 buttons, you can use that one cursor. You can move the cursor. If you shift it, you can also select it, maybe. So maybe you can copy it, Control and C. Maybe you can paste it, Control V. So you can do the thing with with this one. You can also pop up this one, maybe doing some things like this one. Okay. And actually, this is a space keyboard, space mouse here. Actually, you can move the cursor on the space, but actually, inputting this way is very difficult, right? but having the on-screen keyboard here, it's also very difficult for you to input. Even if it's just a single stroke, it's very difficult here. But if I change the mode into, so there's a gyroscope here. So if you put it down, this is 8. So I can maybe change the number. This is 8, right? This is 2. This is 6. This is 4. So if you change the mode, maybe this is H. This is O. No, not. This is H. This is O. Actually, the sensor is not good here. Maybe. This is A with R, E, space. So today I can input with the actual conceptually. So I can maybe this demonstrates a kind of inputting with the gestures, right? This is the number 5 position. So this is number 1, 2, 3. So I can designate the first letter, second letter, third letter that way. So you can input you can select the letters you want that way. Okay. Okay, the other actual demonstrations, you may guess what will happen with my demonstration. There's a lot of demonstrations here, but mostly the same, I think. And another one is there's a dual interface here. So if you are using your hands like this way, you can input, for example, actually, this is another derivation from 3x3 structure for using both hands. So if you want to enter, for example, W, 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 you can use your both hands together to input that way. Maybe symbol, and here dot, maybe G, O, O, G, L, E, symbol, dot, C, O. You can use your left hand and right hand together, so it can speed up the input that way. So what I have shown you is that there's also many demonstrations with the data glove and the shooting gun. Actually, shooting gun, you can, with this one, it's very difficult for you to shot the small button. But if you sync the whole screen into 3x3, you can very easy to shoot the right region. So that way, we can provide many the intuitive solution to text input. And we can also provide the whole keyboard functions by overlapping the layout, whole alphabet layout and the keyboard layout together. So that's it. Thank you.
Have you considered maybe putting up like just a little 3x3 grid in the lower right-hand corner while someone's using the large version so that they can kind of see what they're doing, but it's not taking up the whole screen,
yeah.
Something like that, or maybe just a.
We made some an emulator for doing that, but we didn't do any experiments. Actually, in the last Kai conference, we just wanted the professors or the researchers to do that kind of experiments together so that we can verify that this is a far easier layout and far efficient layout to do the input. Yeah. Yeah.
Have you worked with Korean or any other language requiring an input method?
Excuse me. Actually, my English is not good. So.
Have you worked with Korean as well as English text?
Work with.
Yes, there are some languages like
yes,
where Japanese,
yes.
Chinese, Korean require the input method.
I see. Okay. We did do. We tried to do the same thing for the other languages like Korean because I'm a Korean, but the Korean keyboard is not invented like QWERTY keyboard. According to the history of QWERTY keyboard, it is to avoid the jamming thing. So the alphabet are spread over the whole surface. So that makes our solution possible. But Korean alphabet layout is different. Actually, it's a little bit like the Dvorak keyboard. So it's very difficult for us to make the layout conform to the keyboard. So it was difficult, but we just followed the similar guideline, finding the similar statistics. So we divide the whole letters into 3 groups. And so on, and actually we have succeeded in that. It is faster than current solutions, but of course it's a little bit difficult. MobileQWERTY is easy because you know QWERTY, but the Korean layout is different. And how about the Japanese and the Chinese language? We have small demonstrations here. Sure, excuse me. Actually, this one is for Japanese here. you know, the Japanese people like to input using the alphabet keyboard. So we have invented it. This is Japanese, and this is hiragana. So if we want maybe hello, that is sayonara in Japanese. So if you SA, so SA changes sa. This is letter sa, and this is yo, na, ra. And then you press the space button there to change it. The right, that way we can provide the Japanese Japanese solution and as well as the Chinese solution.
One issue I see with adoption for general mobile devices, you know, cell phones and this sort of thing, the standard ABC, you know, code is pretty hardwired. Companies give out their phone numbers, 1-800 Google,
Yes, right.
you know, this sort of thing. So we're tied to the ABC code, whether we like it or not. I mean, do you see mobile devices supporting both codes, given, or?
Well, we thought about the barrier for the vanity numbers, memorizing numbers, but there's actually already some smartphones that do not have ABC layout at all. So their on-screen keyboard, on-screen key map, ABC key map works for them. So we can also maybe the hardware, if the hardware is equipped with the MobileQWERTY, then the screen can show you the ABC layout, while the hardware is equipped with ABC layout, then the software can display the software keyboard. Let me demonstrate some of the emulator here. Yeah. Like this way, you can see the on-screen key map there. So you can hide it or show it as you like. So then there can be one part of that can be ABC layout there. So actually, one thing I have noticed is that if you want to call the 1-800 flowers, do you know the correctness of your dialing? Let me, for example, if you entered 1-800 flowers, maybe F is 3, L, O, maybe this one. So can you read it, 1-800 flowers? So I can input, for example, using the hourly version, maybe 1-800, maybe F, L, O, W, and E, R, S, and dial it. So you can convert it internally, so you can call it. That is the normal, the practice done by the smartphones, maybe. So I think there's many workarounds for ABC problem, and actually ABC is the most serious problem in inputting. So if people want to do input on mobile devices, they have to change it without sticking into the ABC layout. That's my opinion. Thank you. So no more questions? Okay, thank you.